All right, you guys, for this next example, they want us to show if two composite functions are equal. Okay, so let's read the directions. So it says if f of x equals 3x minus 4 and g of x equals 1/3 x plus 4, show that f composed of g of x and g composed of f of x equals x. And then for every x in the domain of f of g and g of x. All right, so we're going to do this in two parts. Okay, so the first part, if you kind of want to label them, okay, the first thing we would need to find is what f composed of g is. The second thing we would need to find is what g composed of f is. And then we would need to see if both of those equaled x. So even though they didn't label them in three parts, it's kind of like we're doing a three-part problem. Okay. So let's do what I'm going to call A first, which would be f composed of g of x. I need to figure out what that is. So you guys know me, I like the other notation better. G of x. So g is my inside function. So that lets me know that everywhere there's an x in the f function, I'm going to put the entire g function. So let me go ahead and write f. So that's 3. I'm going to put parentheses where x is, minus 4. Now where the parentheses is, I'm going to write g of x there, because it's the inside function. All right, and g of x is 1/3 x plus 4. Okay, now I need to simplify that. Okay, so I can do 3 times 1/3, which is 1, okay, which is going to leave me with x plus 4 minus 4, okay. Then we can combine like terms, so plus 4 and negative 4, that's 0, which just gives me x, okay. So that's what the first one gave me. All right, let's do B, or what I'm calling B, which is we need to figure out what g composed of f is. Okay, so I'm going to write it the other way, g composed of f of x. All right, so I'm going to write my g function, which is 1/3 x plus 4. So I put parentheses where x is because it allows me to see where I need to put the other function. All right, so I'm going to put f inside of that parentheses, which is 3x minus 4. Okay, and just like the other one, I'm going to go through and simplify. So I'm going to do what's in parentheses first. So negative 4 times plus 4 is 0. So that gives me 1/3 times 3x. 1/3 times 3 is 1. So that just leaves me with x. Okay, so the question wanted to know, are these two equal? Yes, they are. They both gave me x. Okay, now they also wanted to know what is the domain of each of those. Okay, so let's go through and look at that. So for A, okay, the domain is interested in the x values or the input values that you can plug in. So we are going to think about those filters again. Okay, so for A, the inside function is g of x, and the outside function is f composed of g. So when we look at g of x, okay, g of x was this function here, okay. All right, we need to look at what type of function it is. So it's a polynomial function, okay. So we have, okay, so for a polynomial function, the domain is all real numbers, okay. And then when we look at f composed of g, which is x, okay, that is also a polynomial function, okay. And the domain is also all real numbers. So for this function, the domain is all real numbers, okay. All right, let's look at the domain for B, okay. So if we're looking at those filters again, the inside function for this one was f of x, and this one was g of f of x. F of x is this function, which is also a polynomial, and its domain is all real numbers. Then when we look at our final composite function, which is x, that is also a polynomial function, when the domain is all real numbers. So the domain for all of these are all real numbers. Awesome. So you just proved that both of those functions are equal. Cool.